So today's presentation is embedded command line interfaces will change your life. And they can be life-changing, as we see. I'm Joe Schneider. I'm the president at Dojo 5, the special guest today. And we also have today with us Joe Perrin. Why don't you introduce yourself, Perrin, and get us started on how they're going to change your life.
Yeah, they may change your life. We let the marketing guys come up with the title, but I'm Joe. I'm a firmware engineer here at Dojo 5. Been here a little over a year. Spent most of my career working in embedded systems, microcontrollers, FPGAs, SoCs, and I've been the software guy in the hardware group, hardware guy in the software group. So I've kind of seen system life cycles from both sides, and I can tell you that you want an embedded CLI. Yeah, and we're going to go over why.
Nice. Hey, and I forgot to mention, but if anybody has any questions during the presentation, please feel free to use either the chat or the Q&A features down below and just toss them in. We'll either work them into the presentation or we'll answer them at the end. So we love questions and it helps with the interaction. So that'd be great.
All right. So with that, we'll get started. So embedded CLIs will change your life. This is an extension to a blog post that I wrote back in February. There's a tiny URL. Thanks, Ryan, for adding that. Or you can search for it. That's the title there on the blue hyperlink. So this is going to be an extension of that. And so what we're going to cover what is an embedded CLI, because you might think, oh, Linux, I have an embedded system, it's got Linux, it's got a CLI. That's not quite the ones we're talking about today. Why you'll want one, some scenarios where CLIs would help, and like what happens when you do have one, what happens when you don't in certain scenarios. What I looked for when I was looking for an embedded CLI implementation, I've written my own before, but with the power of open source these days, and there's just a lot of good solutions for things out there. So I went and looked at the field and found some and evaluated them through some criteria, and we selected one that we now use at D5 for a couple projects and plan to continue to use. We'll go over the embedded CLI I picked. We'll do some in summary over everything we discussed, and then hopefully have some time for questions at the end. So what is an embedded CLI for the purposes of this discussion? So for this, we're not talking like a Linux prompt. I mean, we're going to emulate some of it's also a CLI. We're going to emulate some of those features, but in particular, we're looking at non-Linux based embedded systems. So we're talking like maybe your ARM Cortex M0, M0 Plus, like those smaller, maybe in some 8-bit micros can fit some of this features functionality on there, but basically all non-Linux embedded systems. So maybe you got FreeRTOS, RTX, bare metal, Superloop, et cetera, et cetera. But if you have Linux, then you have a command line, and you should and probably are using it. But if you don't have Linux, you can still have one, and it's important that you do. So we're going to make the case for embedded CLIs. And so I have some scenarios we're going to walk through, but I've been on both sides of these conversations. Hey, I need a build that'll do X, and X could be, force low power mode, or X could be disable accelerometer interrupts because they're waking us up from low power mode, right? But then they come back and they say, well, I need low power mode and the interrupts disabled, and I might also need to stay in low power mode when the charger's plugged in because I don't want it to actually die. And so suddenly you've got one to several builds to implement this feature set for somebody doing some testing, right? And that's important. We want to support their testing, but it can eat into your time. And it might not just be somebody local. It might be, hey, factory line needs to be able to do X. X might be like, we're going to program the MAC address right after programming when JTAG is still connected. So, whatever we need to do to support that. They might come back later and say, well, actually, we're going to do that at end of line now because we don't have the connection to the server to request the MAC address be issued to this device until the end. So then you got to go back and you have to change, how that's implemented. And all of these could have a very simple response, though. Wrong one. No problem. We ran into these sorts of issues during development. We added those commands to the CLI. Just use those, and you're going to be all right. So no more custom one-off builds, like things that you ran into, we added to a feature set that then the larger team can use. And so that could be all of those things we just talked about with programming serial numbers or MAC addresses. And if you instrument your code to give hooks and expose that functionality through a command line interface, then anybody can use it. Software team who's familiar with how to plug in a UART cable, hardware team who might be familiar with how to plug in a UART cable, QA who, it just goes down the list, all the way down to somebody doing a customer demo who, you have to tell exactly what to do, right? Make it very easy if they can just plug in one cable. And we'll talk about, it doesn't have to be UART, doesn't have to be RS-232, RS-485, any of those. We'll talk about other interfaces we can use. But the main thing is that you have an interface that's easy to use. You can type some commands and execute those hooks into your code to elicit specific behavior. So unfortunately, most places I've worked kind of stopped at those prompts. Like, when I was in the hardware group and I was kind of the software guy, they'd be like, "Hey Joe, can you go ask, I'll leave names out, but somebody to go give us a certain build," and I'd go over there and I'd be, knock on the cube wall and be like, "Hey, can I get a build that does this?" And potentially in a hurry because it's holding up our testing, right? And we'd get a bunch of one-off builds, and and over time I push for CLIs and things, and like you can get some pushback, right? Maybe it takes too much time, or too complicated, more code to test, all these issues like, oh, maybe we don't have access to that interface for the full life cycle of development. But honestly, like, it'll be worth it. Hopefully I will convince you of it. And in particular, I'm going to have a line item of how you can convince non-engineering management to sign up for it, because I think that's really one of the biggest features. But we'll get to that in a couple slides. Let's see. Yeah, so use cases for CLI. They're endless. We're going to use it during software development, right? So if you're writing something that turns on some feature and you need to test it a few times to make sure it's working, like on the board or something, use it during software development. Use that little command instead of having a custom build. Use it in hardware development, like if they're doing max power testing to make sure the power supplies are holding up under maximum load. Make that a CLI command. Then you can test max load as a software developer, make sure you turn everything on, and hardware team can use it to make sure that their power supplies are working, right? System testing, manufacturing testing, RMA testing, right? Like sometimes we forget about things that come way later in design, but eventually something will most likely come back broken and you'll want to be able to test it. CLI can help with that. It's a great start for hardware in the loop. Use it for PC Bring-up at your contract manufacturer. And then customer demo. So this is the one, it's a good way to sell it to non-engineering management. It's like, hey, guys, we can simplify customer demos. We can practice exactly the flow that we're going to do, make it in a deterministic way. We can make it into a script that a sales guy can show easily, oh, this is the JTAG debugger that's not working right. Let me grab another one to flash a different build. We're going to go into more details in each of these potential use cases in the next slides, but the use of a CLI is endless. So back to software development. I'm going to pick Wi-Fi for most of these examples. Not all embedded systems are going to have Wi-Fi. Feel free to sub in a Bluetooth or Ethernet or any other feature that a board might have. But so scenario, I need to test Wi-Fi max transmit throughput doesn't affect like my critical thread timings or something. Let's say I'm setting up DMAs to pump data over, and I want to make sure that those interrupts on DMA empty or done complete don't affect the timing of my critical threads that might be taking like ADC samples at particular times. So without a CLI, that's potentially a custom build of code that just boots up and says, hey, start transmitting Wi-Fi packets at max rate. With a CLI, that's Wi-Fi TX max, right? So that can go into your standard build. Doesn't have to be a special one-off build. And then you have it. And then, if you need to, if you really truly need a build that starts up and does that, invoke whatever function Wi-Fi TX max calls. You've already, if for the custom build, you've already implemented some Wi-Fi TX max, just expose it through a CLI so that others can use it. And why would you want to do that? Well, because then the hardware guy comes by and he's like, hey, I need Wi-Fi at max throughput to make sure that my power supply design is sufficient. Like, maybe they have ripple requirements on the electrolytic caps. And he's going to come over and he's going to be like, hey, I need to put the Wi-Fi at max transmit. Great, I already did that. Wi-Fi TX max. if you have a CLI. If you don't, if you just have custom build, you're like, well, here's this build, it does it. Well, these are going to come back. And that may or may not have been me. I'm going to come back and I'm going to say, hey, okay, I've got a problem with max throughput that the system's capable of, but technically we're only required to do like 80%, let's say like 50 megabits per second. Let's give me a build that backs it off to 50. And let me see if we pass. And then we'll just call it good, right? Well, so is that now another custom build? Or do you start to add some interface to let them switch between 50 and whatever max is, like 80 megabits per second? Well, if you started with a CLI, no problem. Wi-Fi TX max or Wi-Fi TX, some value between 0 and whatever the max megabits per second is. Let's say, maybe restricted to increments of 10, some sort of parameter validation on it, but it's simple. And now you have it for your uses to verify that you're not overloading the system when transmitting at the max rate. And the hardware engineer has it so that he can verify his own power supply functionality or anything else. Because what other interactions could max Wi-Fi transmit have on the system? You could have, radiated emissions. You could, if you have also Bluetooth or any other wireless devices, you might have some interference. You have to do some coexistence testing. So you start to see that, okay, I've already, I put in a CLI, it took me some time, but I've already, not had to respond to a custom build request from the hardware team. But let's keep going. System integration guys come by and they're like, hey, radiated emissions under max Wi-Fi transmit. We're doing FCC testing or coexistence testing with other features on the board. So they come by, they want the max Wi-Fi packet transmit build. You can give it to them. Well, then they see a problem max transmit, so they also want to try at a lower bandwidth or a lower transmit speed. Okay, great. I did that for hardware engineer. But then they come back and they're like, well, it looks like some noise is coupling into the line to the power amplifiers. So can I have a build that Wi-Fi is not transmitting, but I can just turn the power amplifiers on and off? Sure, I guess. So is that now a third special build? Is that, again, so now they want configuration options. Gosh, if you just had a CLI, it'd be so easy, right? So you just add Wi-Fi, power amplifier, on, off, right? And if we have a CLI library, it's just adding another function, and you're going to have to implement that feature set anyway to turn the power amplifiers on and off. Might as well expose it through a CLI. So let's keep going. I'm really going to be beating you over the head with these reasons, right? So I know these are a little over the top, but these are all real things I've run into and why I'm very adamant about CLIs, right? So this was recently with the customers, like, okay, we have a safety critical circuit and I need to make sure that in the response to a fault, everything happens correctly. Well, the hardware team is not finishing building the device that can trigger a real fault on the hardware, but I want to test the rest of the flow through software. Say the software sees a fault, sees this fault, I want to make sure that my relays open in time on triggering that fault. So he comes to you and he's like, hey, give me a build that triggers this fault. Well, okay, here's a build that boots up and faults. Well, great. I want to run it, hundreds of times. I guess I need to restart the board, but we have a 15-second boot up. My cycle time is going to be real high. Well, if you had a CLI, you could just give them Wi-Fi. It might not be a Wi-Fi fault. It could be like, in particular for this customer, it's an electrical short. So like if you have a power supply line shorted or a brownout, they could trigger a fault. Something happens to your system, and in this particular case, we try and open some relays. So if we give them this hook, they can test before the hardware teams rework some boards to be able to actually short some power supplies on the device, and we can make sure that works. Well, this also works for you as a software developer, right? Somebody comes and says, we trigger this fault and it doesn't work. Well, what's the first thing we do? We try and bisect the problem. Okay, is it that way or is it that way? And this Wi-Fi fault or this fault command gives you the chance to be like, okay, let's make sure that the software can handle a fault. Okay, the relay's opened. That means it's somewhere where we detect that the fault occurred and not the actions that we take when that fault occurs, right? So CLI, again, this time you wrote it for somebody else, but it comes in useful for you. It comes in later for testing. Manufacturing testing. So manufacturers are going to come to you, say, I need to connect 40 units on the line to a particular SSID, which may or may not change during the lifetime of this device is in production, whose password may or may not change. So I need a build that does that, right? Okay, again, don't necessarily want to do a custom build with a hard-coded SSID and passcode, so we give them a command line option, Wi-Fi connect, SSID, passcode, and then they can start a ping, right? You just give them that option. Again, this is probably going to be useful for you. Hopefully, manufacturing is not when we found out that we had a problem connecting to SSIDs and pinging a device over Wi-Fi, right? So we could definitely use these way earlier in development. And so they might already be available. So you saved time, because if you had already implemented this early on in the project and made it exposed over a CLI, manufacturing team can now use that on the line, and you might not even have to hear about it. They might just be like, oh yeah, we use that. Which takes me to another point. If you end up doing custom builds for things like this, like, okay, do you save those as like a patch set? Is that a branch somewhere that you have to go rebuild? What happens if there are other updates that interact with that? Do you need to go rebase that, reapply that patch set, rebuild? How are you even building these one-off builds? Do you have them as part of your CI/CD? Are you capable or ready to handle potentially like 10, 20, 30 additional builds nightly? Because you don't want people out there using old builds to test. You want them on something as recent as possible. And if you implement a CLI and keep that up to date as part of the main build, it's always available. It's always up to date. They don't have to say, well, I've been using the build from 2 months ago because it's the only one that had this feature I needed that you implemented for me. RMA testing. Unit comes back from the field. They say, yeah, Wi-Fi goes out after 2 or 3 days. So we want to stress it and see what we can do. Okay, great. Wi-Fi connect, SSID passcode, Wi-Fi ping IP, maybe throw in a Wi-Fi max transmit. So it just tries to send as much data as possible. Maybe it had something to do with transmit. Maybe the power supply wasn't actually capable, and we have something way off a couple standard deviations away from the mean where it fails under max transmit. And then logging, right? So maybe this gives access to your logging mechanism, which hopefully you also have in your embedded system. But you turn on verbose logging, and there you go. And that would be great, again, for you, for hardware. It's like, hey, we're running into an issue. Okay, log accelerometer verbose, log Wi-Fi verbose, whatever logging system you have, be able to up the logs when you're looking for a problem. Hardware in the loop testing. So hardware in the loop testing is awesome. It can be difficult to implement. It can be difficult to set up the first time. But if you already have hooks into all of the functionality of your system that allow other people to do tests, then you can very easily automate that. Because so here's the problem: is like you have all those custom builds. And let's say they're all up to date, they're all on CI/CD. How do you actually test them to make sure they're doing what they're doing? Well, if you don't have a CLI, you're probably going to hire an intern, program each board, test it. Maybe you can automate that, but why go through that trouble when you've already implemented a CLI and now you just need to have PyTest or something sending commands over UART and seeing that it does the correct thing in response. So you've already instrumented your whole system by implementing the CLI to give all these tests for all the other groups in the company. And now we can use it for Hill too.
That's really funny that the hire an intern is the I feel like, because we've done other webinars in the past, right? In the recent past, we've been doing quite a few, and it's funny how often that comes up. And I feel like a lot of modern embedded. I'm just curious your thoughts here, Joe. Just for a pause, is like, it's curious how many times like the right thing to do is something we don't have time for, but we're going to have an intern do it. You know, because they have time to do it, but like the professionals that are working on it, they don't have time to do it. They've got the hard bugs to put out. So, I mean, don't you feel like, like a lot of what you're saying here, and we'll continue to see some more examples, but is like, a CLI is not just like a nice thing to have. It's something that like can become a critical part of your workflow and really enables your team to like move faster, and more predictably, right? Because you've got, like you say, you're not managing all these various, one-off builds that you can't trace. It's critical for everything from, mechanical and electrical and RMA and manufacturing and like certifications and all of that stuff. It's like all of these things need to be done to get this product out the door. You need a way to do this, but it's just something that for some reason we don't focus on as an industry, right?
I don't know why. Maybe I just worked for the wrong companies, but like, because I was this intern once, and it does look like a lot of upfront work often, and like maybe doesn't fit into the model of how you've structured your code. But we'll talk about why it's maybe not as difficult as you think here in a few slides. But I think it's just one of those things. It's like if you don't do it very often and you haven't like experienced it, it can be a little daunting. And it doesn't have to be daunting. And even if it is, it's completely worth it. And it helps. Go ahead.
Oh, I mean, it's slight pitch for D5 here is like, one of the things that we're trying to do is identify these things that aren't typically in a firmware engineer's like back pocket as things they've done over and over again, and trying to make those things, easier to access. Things like hardware in the loop testing on our Embed Ops product, or even things like, when we, like you're saying, when we, as a company, we invest time, in choosing a CLI and then gathering knowledge, building knowledge internally about how to use that CLI, so that when folks come to us with projects, we kind of have a go-to, right? And then we can get them started very quickly and they can take it and run. So that's, I think, not just what D5 does. There are lots of places, but we're specifically looking at the modernizing embedded piece. And that's where I feel like, a lot of the industry has kind of lagged behind a little bit, because you get these the managers types who are like, I never did a CLI when I built embedded systems. We don't need it. Like you're just shiny object syndrome or something. Engineers, you don't, this isn't really necessary. We don't, when back in my day, we didn't have CLIs. We debugged with, oscilloscopes or something. So, screw this. So, yeah, I mean, do you feel like, I don't know, well, just maybe something to think about. Maybe we can revisit it at the end, but it just struck me. Hire an intern is like, maybe it should be like a trigger. If you see your team or if you yourself have this like inclination to like, I don't want to say I'm anti-intern, but if your idea is like, let's do it right, but let's have the intern do it right for us, that's probably, it feels like an anti-pattern.
Right. Have that intern work on the CLI if you have to.
Yeah.
Instead of just resulting straight to menial labor. But hiring an intern's a win-win if you can get the intern working on the correct thing. Sorry, I think we may have lost our recorder, but anyway, without SCI, maybe hire an intern. I like interns. I was this intern. It is a good way to get them, some experience, but let's get them integrating the CLI, making the system better, not just doing the tasks that we don't have time for, that aren't pushing the product forward. So okay, move on to the next slide. PCB Bring-up. Right. It's manufacturing time. You got your contract manufacturer. They're about to build 5, 10, 50,000 units. I worked for a company where one of the early pilot builds was 10,000 units in preparation to start hundreds of thousands of units. You want to know if all those boards are working before they pack them up and ship them. So they wanted a build, that boots up, self-tests, blinks some LEDs. Well, let's just make sure that we've been testing all those self-checks from the beginning and have a self-check CLI command, right? Same thing. Now, we might give them a build that automatically invokes self-check, but really, most contract manufacturers, they're going to be doing something else with JTAG or UART or some other interface. They probably won't mind to plug in. And once you're in those quantities, you're pulling something down, it's coming down, pogo pins, something. Running a command won't be a big deal, but you should have that command in there from the beginning because it's good for debug too. It's like, hey, my board's doing something weird. Run the self-check and see if it catches anything, right? And then if it doesn't and you find something new, add it back to the self-check, right? So CLI, still important, even if it does become a custom build. I'm not saying that custom builds aren't ever going to happen, but we can avoid a lot of them with a CLI.
Yeah, I've seen a lot of things too, just on that point. The like you say, the JTAG, you could have like an auto start command, like a like a space in memory, that like just a big blank array. And, as part of the boot up sequence, it checks that area in RAM to see if an instruction has been set there. And if it hasn't, it just boots normal. But if it does see an instruction there, then it will, automatically runs it. And then something like a JTAG or a JLink can toss the self-check command in there and then boot the system at the end of the line so that it can, and then you don't even have like you say, a custom boot, or like things like U-boot, have this accommodation for like a boot script and other bootloaders. So the really common thing.
Endless possibilities. I've seen it as easy as an IO pin's boot up state, being grounded or pulled high.
Sure.
But yeah, that, and I mean, I'm going to jump into interfaces later, but a big one is when I say JTAG, Segur RTT, which is also usable by Pi OCD now. You have JTAG, but you also have, a UART, a, ASCII interface there. And actually, when we talk about the first time I implemented this CLI that we chose, I used RTT. But yeah, so PCB Bring-up customer demo. So customer comes in, they want to see a demo of something, of the product, it's sealed up. They wanted you to turn on, and one of the things they come in while they're doing, like, oh, this is great, except can you do, exercise the Wi-Fi in like a max transmit, because we had a problem with the last version, would get real hot right here where the person's holding it. Oh, okay, well, we had an overall temperature spec, but we didn't have a hotspot spec. And if you don't have a CLI or a hook to do this, they might be like, you will have to go through this process of, okay, yeah, I can do that. I know we have a build, so let me open the case, find a JTAG programmer. If I'm not a software guy, find a software guy that has a working one. Go get that build, which may or may not be built every night. So maybe now I have to check out the branch, program the device, put it back together, yada, yada, yada. I'll be back in 30 minutes. With CLI, okay, maybe UART's not accessible anymore, but maybe when the unit's sealed, you forward specially crafted packets over Wi-Fi and run them to your CLI. Right? So now it could just be a Python script that says, oh, okay, let me just run this script the software guys gave me, and boom, max Wi-Fi transmit. So some of the times when I say CLI, I don't always mean just typing at your keyboard ASCII. I mean, the hooks into the system. And so I ran into something just like this working for a company. At the time, I was responsible for the front panel LEDs. And they were very particular about the color blue. And the blue plastic matched the Pantone color. I mean, as part of, they had sent us email like, oh, we don't like the color blue on the front of yours. We like your competitors more, or the other contract manufacturers more. So I went down to the hardware guys, and they're like, well, the Pantone's right. And we actually had a copy of the other manufacturer. It's like, well, their Pantone's wrong. But it turns out the customer actually liked the other Pantone. Anyway, we found out it was also a function of the luminescence of the, like, how bright the LED was. And so I asked software guys, okay, give me something that just steps through the LED brightnesses. And they did. And so like we showed that to them. They're like, great, we don't like that lowest one, but that second to lowest one is maybe too bright. Like, what's right in the middle? I'm like, well, I don't have a build that gives me right in the middle. So that was a call for another software build. Luckily, really in the meantime, I had a constant current supply that I had wired up into a board with a potentiometer. So I was able to sweep the brightnesses and back calculate for the software guys later. But if I had a CLI that just said LED set brightness, X, I could have done it right there. And that's probably how you would implement something like that. You wouldn't say, oh, here are the steps. You'd say, here's the PWM duty cycle. Here's the luminance value, and specify it that way. So this is a great way, customer demos, to get non-engineering management buy-in and be like, guys, we can make demos smoother. We can practice demos in a deterministic way. And we can be testing those functions for months before we're ready to put a full demo together, right? Like, we'll be piecemeal and iterative testing of all the features, and in an easy way that we can even put in front of salespeople earlier on, or we can script for them. I've used PuTTY, used Python to script serial ports, but TerraTerm is, lots and lots of people, everybody, software engineers, hardware engineers, even management people know what TerraTerm is, and you can script TerraTerm. They actually have a decent scripting language as well. So yeah, so customer know. So hopefully I beat into this pattern here that you have a problem. You may have done a custom build in the past, but really a CLI is going to save you a lot of time because other people are going to ask for the same or very similar things. And it's going to be a heck of a lot easier to manage and maintain and keep up to date a CLI as opposed to all of these custom builds. And then the problem is like, okay, what if you don't just have Wi-Fi? What if you have Bluetooth or Wi-Fi, Bluetooth, GPS? Now you have all these permutations and you're going to start generating a lot of builds, or you just need to make sure that your CLI, those hooks say, I can turn Wi-Fi on max transmit. If it's a separate Bluetooth transceiver, you can turn that on in max transmit. You can turn the GPS on and see if you've got coexistence issues, right? And when your systems guys are doing systems like FCC regulatory tests, they're going to run all those things. That max power test, it might start out like, okay, we've got the Wi-Fi driver working. We'll do max power Wi-Fi. Hey, we got the Bluetooth driver working, or we got the GPS driver working. We'll add those to the max power. And that, as you've released those builds and those features, automatically, when somebody runs, maybe it's not Wi-Fi max power anymore, but like DUT max power, DUT, device under test, that command can stay up to date. And so now it's like, oh, hey, power jumped from version, tag 1.0.0 to 1.0.1. Oh, that's when we turned on this feature. And, that's the added power from this peripheral. So, yeah. So again, CLIs. So summarize those scenarios. I kind of already did, but stop spending time building individual special builds, get economy of scale with multiple groups using that single hook, that single embedded CLI. Avoid groups using old test builds because it had that one feature I needed. I've heard that a lot in the past. One build to rule them all. So like if you got that CLI on there and it's ready, on every build. Purposely cause faults is a big one, right? Like our normal test flow, we don't always purposely cause faults, but if you can write that for your CLI and get you in that mindset of purposely causing faults in your system to make sure you handle them correctly, the easier that is, the better, the fewer bugs you'll probably find in later stages of development. Let's see. So now you're all sold. You're all going to go out, get a CLI. So we're going to cover real quick the CLI implementation that D5 uses and the criteria that we use to pick it. Though that's covered in much more detail in my blog post, we're going to do a high level here. Then we're going to talk about interfaces you should support, not just UART, pitfalls, caveats to everything I just said. They're not many, but a couple. Summary and some questions. So important features. So for us, because we have customers and we want to modify and ship code to them, we want an open source permissive license. Communication interface, not tied to any particular interface, so not just tied to UART. Bare metal, no RTOS dependency, basic shell functionality like echoing as you're typing, backspace because I still make errors when I type. And I hate interfaces where you then basically have to hit enter and start over because chances are I'm just going to get frustrated and make more mistakes the next time. So backspace is important. Programming language, C, maybe C++. I did not find any in Rust. We're starting to look at Rust for embedded systems. If anybody out there knows about a Rust-based embedded system CLI, I would love to know. But I think all the ones that I evaluated were actually C. Function pointers for for transferring received and transmitted data into the CLI, into and out of the CLI, makes it really easy to make this transport layer agnostic. And I believe everyone I evaluated did use function pointers. Unit testing. D5 is really big on unit testing. We think it's the modern right way to write software. So finding a CLI that already had unit tests was a desirable feature. Static allocation of all data and memory usage, which is generally a best practice for an embedded system. Minimal files so that we're not having to add like 20 files to our build system. I think they all ended up being between 2 and 4. I was hoping to find like a crazy header file only implementation because it's fun to see how people do crazy stuff in just header files sometimes, but unfortunately I did not. Built-in command help. So you get somebody hasn't looked at the README and they're like, what does that command do, right? It'd be nice to have a CLI that has integrated first class help support. So each command, you can type help the command. And then runtime command minute registration. This is a big one for me because I like the flexibility it gives you. So what that means is they're not all your functions that can be called via CLI are not known at compile time, that you can determine at runtime and add some. So you statically allocate a big array of all the commands and or a big chunk of memory that can store commands, and at runtime you copy them in there. And what this lets you do is it adds something like security. It's like, okay, I'll let you get the version information, but anything else you need to type unlock and the password, and then you can check the password and add all of those functions to the CLI. Or even based on different builds, like maybe your release build, you remove all the functions that aren't you don't want available for release, right? So you don't want necessarily if you're doing some sort of crypto key store, you don't want to leave in dump crypto keys in the CLI.
Yeah. So I mean, quick customer story there too. Like we were hired in the not too distant past to do a security audit of an IoT home product. And on that product, the initial it was even spelled out what to do, right? There's some typical security things you do, like blow the JTAG access fuse, right? So nobody can JTAG into it later. But one of the things right on the line item was disable the UART. And in this case, they wanted the UART disabled, but it was wide open. And not only that, this UART had a bunch of these CLI commands that were great for development, but I could dump the Wi-Fi settings on this device, IoT device, like I mentioned, and it would happily give me the password and the SSID for whatever it was. And that was, so really glad that you mentioned that security piece, because it is while these are super important, I think, for development, and there is, of course, that's one of the obstacles you might hit when you're trying to convince your manager to do it, or when you hit the quality guys or SQA, they might be like, well, wait a minute, we're never going to put this in because I don't want the liability of, having it in later. And all of a sudden this code gets run, somebody, maybe you've got you're coding up that, $10,000 upgrade in the field, right? Click the button and pay us $10,000. And then somebody figures out, wait, if I connect with a UART, I can just code myself up, a new minivan or whatever. So that's kind of what I'm glad you mentioned that, because that's an important piece too.
Yeah. At a previous job, I was very focused on security. So it's, I hope it comes to mind all at the right times. But don't expose things that you don't want the general public to be able to access later. Put in features for that right at the beginning, passwords or build flags, whatever's needed. The
FDA is quite is really looking at this too. I don't know if anyone online is doing some medical related stuff, but they will catch you even if if you use the same password on every device. That's a no-no. You got to have device independent. And then they even really want to understand, is there dead code? Depending on the class, how security critical it is or safety critical it is. They want to know, if there's code that might harm a person, they don't even care if it's dead code. Could the device jump to that code and start running it, even if you're not expecting it to, and what would happen, in that case? And so it's things to think about. So, I'm glad you brought up the whole, in a production build, you might just compile that all out or something.
Yeah. So embedded CLI. So I looked at these 5. I found easy, and they were all open source and permissive licenses. There were a few out there without that were closed source, but they actually ticked most of the boxes. This list, I actually, in the blog post, I have some additional criteria and where they differentiated a little bit better or a little more. But you can see only 2 had unit testing, and so that had us looking at both of those. And I ended up going with the Fun Biscuit CLI because one of the features it had that I really liked was autocomplete. So you just hit tab a couple of times like you do on your Linux system, and it suggests available commands. You can turn that feature on and off because you do have to take into account okay, this is going to add some RAM usage, some flash usage, and some CPU cycle overhead. But it's configurable and definitely worth it. And so after that, I integrated into a project, made my own little Sorry, made my own little demo here with GIF. So I have a function there to runtime add additional commands. You can see I type some here. I'm typing like, oh, I made a mistake, backspace. Then runtime add, I tab completed that. I didn't have to type it out. That added a new command, test1, and that was runtime added functionality. And it has history. So I was able to click up, rerun a command I'd already written. Awesome little project. This guy did a great job. Fun Biscuit in the embedded CLI. So that's the link to his GitHub. Really awesome. So D5's trying to use this on projects going forward for our customers. And I'm going to rush a little bit here because we make sure we have some time for questions at the end. But I originally implemented that over RTT for our system. Real easy, function pointers, and then like we integrated into FreeRTOS. So occasionally we call the process command for the CLI. So it processes the incoming bytes by calling the function that we passed in as a function pointer, and it runs over RTT. Well, coworker was recently working on that, and they got the USB virtual COM port working. So it's USB to this device all the way to the microcontroller, and has a virtual COM port driver. And they rewrote it so it works over that now too. So now it works over RTT and that COM port on that project. And virtual COM port is much easier for most people to use, and not everybody has a Segger J-Link, though it works now on PyOCD with ST links and probably some others. But all that to say, don't take away CLIs, just UART. Like oftentimes we think about that as our terminal emulator on the computer for Linux, or command window, whatever. Or we think about UART for Linux systems. They still have a UART. You can access a terminal often. It does not have to be UART. So, and it's so easy to make it any of the interfaces, but think about UART, RTT, PyOCD, Bluetooth, USB, Ethernet, Wi-Fi, any custom interface, heck, even I2C, right? Like if you can get data to it, you can process it. And you don't even have to process it as ASCII. Like if you need to write a binary implementation, like that sends like an enum, and based on that enum, you call these hooks that these command line functions were calling, right? Like you already have all those hooks. What the CLI forces you to do is instrument all of your code. And I think, well, we'll talk about that later. But yeah, so any interface. So somebody says, oh, we don't have UART when we have the plastics on. Great. Let's move over to RTT. Let's move over to Bluetooth, right? Like that's not a reason not to have a CLI, because the interfaces might change during the life of the project. So pitfalls. Right. So I had a customer, they had a CLI, they had Bluetooth, they both kind of implemented their own hooks, and they behaved slightly differently. And so basically they did the work twice because they were kind of happening in parallel. But if you do this once, then you don't double that effort, and they'll behave the same, because they ran into the problem like, oh, manufacturing wants to do this feature that's available over Bluetooth, but on the factory line, Bluetooth is not reliable enough because we have hundreds of these devices blasting in the Bluetooth spectrum. So we're just going to plug the UART in because the plastics aren't on the device yet. Well, it turned out that the UART interface was different and implemented differently. So if you implement this instrumentation, use it everywhere. Use it for all the various interfaces, especially if you've got something that Bluetooth, something that's going to be an IoT device over Bluetooth or Wi-Fi. Make sure that as much as you can, that they hook into the same code path to implement that functionality. Hitting this again, leaving the interface exposed on release builds. So maybe on release builds, the CLI is just disabled, or it has a reduced set of functionality that are maybe Git commands only, no writing, and only Git on software version, things that like you would use to identify the device. And don't tie yourself to a single interface. So it's kind of all comes back to that. Like, don't, like, I'm trying to think of an example, but don't do anything that would tie you to a single interface. With the function pointers, it's pretty difficult. Like you pass in a function pointer it calls when it needs to get bytes from whatever the interface is. It's pretty straightforward. So it doesn't have to be a CLI, right? Like it does, like I've kind of alluded to earlier, it doesn't have to be, I'm actually at my keyboard typing, I'm actually using Term, I'm using a RS-232 adapter. It just needs to, what we've really hopefully conveyed in this webinar is that you really should thoroughly instrument your design from the beginning, and expose it via CLI. Because for those humans, for that hardware engineer sitting at his desk, it's going to be a lot easier for him to type on PuTTY or TerraTerm than maybe he would even feel than running a Python script. So if you take anything away from this, instrument your code really well for test, but also expose it with a CLI over whatever protocol transport layer you might be using, and make it sure it's one that's easy. Like if you make it JTAG into like a raw piece of memory, well, then everybody's going to need a JTAG adapter. And that might be more than people want to invest because they can be expensive or they can be hard to get. I've been trying to get an isolated, electrically isolated JTAG programmer from, I think it's ST-Link has one. They were out of stock for a long time. Yeah, so, but, you know, RTT, you can use a cheap ST-Link potentially, but no reason not to potentially expose it over UART as well, right? So, summary. Some software developers like to be efficient, maybe less typically known as lazy. So CLIs let you be lazy, right? Instead of all those custom builds, we're doing just the CLI once, and everybody can use it. It gets us into a repetition of making our code easy to test, right? We write our code in such a way that we can hook into it the same way that commands come from other places. Like, you know, if that's a remote control that eventually invokes some behavior like channel up, write a CLI hook for, or, you know, on top of that, that says, let me issue channel up, because then you can script it. And what happens if I go up channel up 3,000 times? You know, right? You hopefully will loop around eventually. And then you can easily produce specific system behaviors that are hard to elicit without explicit hooks in the system, right? So back to, hey, this particular fault needs hardware support to generate, and the hardware's not ready, or we only have one of them and we need to do some other testing. Like, let's invoke it via software. Is that enough to get us past some of that testing? Because what we're really interested in for some of the testing is not necessarily detecting the fault, but our response to the fault. And having a hook in the command line interface to force those is going to be really useful. Perfect. 10 minutes for questions. That's all I had to say.
Nice job, Joe. Yeah, thanks for that. That was awesome. We don't have any questions yet, but a reminder, if folks have questions they want to ask, toss it in the Q&A or the chat. Either way is fine. And I've got a couple. Yes. Oh, thank you. So Will just we just had another question that actually I was thinking about too. What are your thoughts on like implementing a CLI? And maybe this is maybe not quite what Will was thinking, but the using something like MicroPython or embedded Python in a REPL, because they have like a CLI sort of that you can.
Yeah.
You know.
If your microcontroller has the space and you want to do that, sure. I would have loved to do that on a particular project I'm working on, but it's not got. We're out of Flash. So
yeah,
right. So that.
You hit that pretty quickly with some throwing in. I'm not even sure what the MicroPython footprint is, but it's probably.
I'm not either. But the Fun Biscuit CLI with all the bells and whistles is under 4K of Flash on an M0 Plus.
Nice. So
and that's with debug turned on and probably compiled with O2. So OS might be smaller. I think I put it in the blog post.
That's nice.
Yeah. So yeah, MicroPython, great, go for it.
Nice. And then, and I'd say one other thing I was thinking might be an interesting question is, what have you seen in terms of like you're working on some safety critical systems and you have in the past. How does the CLI interact with like a state machine, for instance, and how do you avoid causing really weird states? Like, is there a certain way that you've constructed them in the past to make sure that?
Unfortunately, I don't have a great answer to that. In some ways, like this can get complicated, right? If you have a complicated state machine and you can't just emit events, right? Like if you have a lot of state between, ADC samples coming in, things like that, like you got to plan up front. Like the only time I've seen it go well is planning up front where, okay, ADC values are coming in via queue, like in FreeRTOS. So I've got a CLI that can pump that queue full of already known data. I've got a test vector already as part of that CLI command. you're going to run into, you're probably going to run into something, but hopefully with enough upfront planning and a well-constructed state machine. And I know that that's a really wishy-washy answer, but
no, that's fine. Yeah, I mean,
you have to be careful.
One solution I've seen in state machines is when you usually state machines have some especially in a multi-threaded system, there'll be some kind of funnel that basically funnels all the events into a queue, and there's a single queue that then gets processed on a tick or something, right? And so if your CLI, it doesn't get too incestuous and starts messing with the internals of the state machine, and instead, you say, or maybe there's a subset of commands that only get to go through the queue and then retain the system state, and then you can tell QA guys that are because the QA guys will figure this out. They're like, hey, did you know you could just type crap into this CLI and throw this system into all kinds of weird states? They'll file a bunch of bugs, whatever, right? And then you can say so these commands are on limits. I want you to find the bugs if you run these commands because they go through the queue. But these other commands that are twiddling it's deep brain surgery on the micro, then those doesn't all bets are off when you play with those. Don't turn the Wi-Fi transmit to 0 and then tell me that Wi-Fi doesn't work, as a bug. Right.
Or try and run a throughput test if you've implemented iPerf or something on it.
Sure. Yeah.
Actually, that makes me think now. I had not thought previously, but maybe you do need to segment or expose, or even in the help of it, say this one messes with internal state, or this one just submits an event to the queue. Because definitely, the state machine should be receiving a queue from different places. It's when you've got something like the ADC module is deciding something happened and it submits a queue or an event to the state machine, and the state machine changes state. Well, if we just send that event, the ADC module is probably still not, it hasn't thought that things changed. And so it might be behaving differently than it normally would. So you have to think about that flow.
And the audience for the CLI, right? There might be an audience that's maybe less technically, or they don't understand the internals of the code,
right? And
so you may want to make it more user friendly for some, commands versus.
That's
others.
why I don't know if I talked about it. It was in one of my presentation notes that you guys can't see, but if you have a max power usage for the device, right? It might be that at very beginning, you've got Wi-Fi implemented. It's easy to put Wi-Fi to max TX transmit that uses some power, but then you bring up the next device, like an accelerometer or something that uses some power. You can add that. You can create a new command just dot max power and add the initialization to bring up Wi-Fi and the accelerometer there, right? Make some higher level functions that can then do all of that correct state, right? So if you just leave it as Wi-Fi to max and accelerometer to max, read it, spam it, reading it, there could be interaction there, right? If you're streaming, accelerometer reads out Wi-Fi and you've turned Wi-Fi to max transmit and turned accelerometer to max reads, that module might be trying to spit stuff through Wi-Fi as well. So
sure,
if you just have a max power usage command, you can make sure to handle those interactions.
Yeah, nice. Let's see, a couple more have popped up. Concerns about leaving a larger attack surface for the nefarious types. We kind of addressed that already a little bit, but
that's why you want to do release build. And I mean, so it really depends on your threat model, right? Okay, are we worried about the CLI if we've left JTAG on there and enabled? Okay, if you've locked down JTAG, then we need to really make sure that we're also not leaving something open via UART. But again, we can compile out that code completely. We can protect it by a password so it's not even accessible, that those function pointers don't get populated into the runnable commands until that password's there. And I mean, definitely we can go talk about that endlessly. And but it all depends on your threat model.
So then a related question is, so if you disable CLI in production code, then how do you enable it back when you want to debug it since it's disabled?
Right. So depending on if you don't build it to release build, maybe OTA is something that you leave in the CLA. Hey, I can program down a signed new image, signed and authenticated and encrypted, preferably, maybe. And so you could bring in a new image, a debug image that has it, or again, that password enabled, on release builds, maybe all commands except for get software version are password protected, and then you send the password in. And when checking passwords, right, you should hash it, then compare against a hash. There's lots of other things. Unfortunately, not the focus of this particular presentation.
But definitely security in embedded systems is a huge topic. Yes, for sure.
Yeah.
There's a comment here just saying from Steve, just saying, hey, like something nice to have is like a show build command or something to like spit out a pretty like a lengthy version string basically that can include lots of other stuff on it.
Should do a git describe, should be in there somewhere. So you get your tag and your hash. When it was, hopefully it was built on CI. If you have any sub modules, you might want to include their versions. Like, we try and be pretty verbose about what we print out to ID builds. But yes, I agree. Yeah,
a show you could have an even, yeah, exactly. Let's see. You got another thought about if you leave your CLI hooks exposed to Wi-Fi, BL, LoRa, you might as well just make the firmware do nothing but wake up so it can be controlled by Alexa or some equivalent. What are your thoughts on that? So like the CLI becomes an API almost for other devices to interact with it. It's like an intentional API.
Yeah. Be ready for an if then that.
If this
sort of interface or if
or Zapier or whatever you use. Yeah.
I had only done that because we couldn't reach the UART before, but it could easily become new features for the product, right? If you've got all these hooks, somebody creative might be able to come up with a new way to use it.
Yeah. Very cool. And then just a couple more. I'll just blaze through a couple commands. Another useful set of commands Steve's saying is something for like fault injection, which would simulate hardware errors that are hard to trigger deterministically. So I think you had mentioned that before, but that's super valuable.
One thing I didn't put in this presentation, but I do have a list of must-have like functions or like CLI commands that I have. Maybe that needs to be another presentation, but it is things like inject faults, get software version, program MAC address, program serial number, get all those things like and this is when you're first integrating the CLI into your system. If you can come up with that list, because like manufacturing is going to need that way at the end. And if you can have it right there at the beginning, it's even more useful for everybody.
Nice. And then just a comment too that, and I actually did this on some products in the past, but one way to kind of get into a tech mode or maybe enable the CLI might be like odd interactions. If it has buttons or a screen or something, like hold something down for 20 seconds or press the button 10 times when that's abnormal or whatever.
Technically that's security through obscurity.
True. So if you read true security, don't do that. But if it is kind of just like it enables some things that, some
secret menu.
Modes. Yeah. Cool idea. Good point. Yeah. So awesome. With that, I think we're going to shut her down. Thanks so much, everyone who attended. And if you have any other thoughts, questions after this, we'd love to hear from you. And next up on October 6th, we're going to have our awesome firmware engineer, Steve Branham, joining us to talk about top skills for modern embedded development. So looking very, very much forward to that, and hope you'll join us. Thanks so much. And thanks, Joe.